Hey there, everybody. We're going to do a little lesson over Chapter 2, Section 4. So, this is all about the difference in classifying matter. So, I've got a little flow chart here that'll help kind of walk you through everything that was in that section. So, first of all, matter is, of course, anything that has mass and takes up space. So, pretty much everything, right? What's not matter? So, like light, doesn't have any mass, doesn't really take up any space, but it is a thing that exists, but it wouldn't qualify as matter. So here we go. Let's walk through types of matter. So the first question you can ask yourself is, can it be physically separated? If the answer to that question is yes, then you have a mixture. If the answer to that question is no, then you have a pure substance. So when I say physically separated, we're going to talk about separation techniques tomorrow more, but just through some sort of physical change or, using the physical properties. So let's say I have a mixture of paper clips and sand, right? I can use a magnet to pick out the paper clips. That can be physically separated. That's a mixture. On the other hand, if it can't be physically separated, you probably have yourself a pure substance. So, what are pure substances? Pure substances have specific chemical compositions. So, two types here, you have elements and you have compounds. Let me get my pointer going. Sorry, my voice is going out. So, element versus compound. In your lab kit, I gave you a copy of the periodic table of elements. So anything on there is an element, okay? It can't be broken down any further than that. So can it be chemically decomposed? The answer is no. The answer is an element. So these can't be broken down any further unless you're like splitting atoms, and we'll talk about that another day. So on the other hand, something like water, H2O, that has hydrogen and oxygen in it. You can chemically decompose that. That is a compound. Okay, now let's go over to the mixture side. Two different types of mixtures that we talk about mainly are heterogeneous and homogeneous. So if you look at the prefixes here, homo means the same, hetero means different. So homogeneous mixtures are the same throughout. So if you take a sample from the top and a sample from the bottom, you should get the same amount of particles of each type of thing in the mixture. So that an example of that would be a solution. So if you are in the chemistry lab and you have certain solutions that we mix up, that we might dissolve something in water, and we have a very specific concentration of that thing dissolved in water, those are solutions. So each group, when you come up and measure out 10 milliliters of that solution, you should be getting the same thing. A heterogeneous mixture is not thoroughly mixed. It's not the same throughout. So if you think about your orange juice at home, if you don't shake it up and you just start pouring glasses, whoever gets the last glass is going to have a bunch of pulp in their glass, where the first person didn't have any pulp in their glass. So that's an example of a heterogeneous mixture. Eating a salad, that's a heterogeneous mixture. Not every bite of the salad is the same thing. Now, I'm not going to spend too much time on colloids and suspensions. That basically has to do with the size of the particles in the mixture. We won't worry about that, especially since every time I look at it, it covers it up. So, when again, run through here, ask yourself, can it be physically separated? If so, then it's a mixture. If the mixture is the same throughout, and every single bite's exactly the same, that's a homogeneous mixture. If it's not, and every little sample could be different, then it's a heterogeneous mixture. If it's a pure substance, if you can break it down further, then it'd be a compound, like H2O. If you can't, then it would be an element, and it would be on the periodic table. So here's just a quick little example of heterogeneous, homogeneous mixtures here. So if you have a granite countertop at your house, there's a little picture of some granite there before it was, shined up like your countertops. But you can see all the little crystals and things that are in there. It's a mixture, and not every single piece of it is looking exactly the same. So it's a heterogeneous mixture. Here's some apple juice. Apple juice tends to be homogeneous, so every drink you take is pretty much the same throughout. And tomorrow we'll get into ways to separate those mixtures. So, good luck.